let's look at problem B from this the first diff for Codeforces contest. So what's going on here? We have get two integers n and k, n up to 1 billion, k up to 100, n as the sum of k positive integers that are either all even or all odd, right? That's what have the same remainder divided by 2 means. It's either all even or all odd. Yes, that's what it says. Okay, and if it doesn't exist, then report it. Fine. So for example, 10 as the sum of 3 numbers. Fine. I suppose they have to be positive. Yep. Okay, so when is this impossible? It's impossible if k is even and n is odd, because the sum of an even, even number of numbers that are all either all even or all odd is always going to be even. There's also some cases if like k is bigger than n, it's impossible. But yeah, it should basically be fine. Right, and we can see, 8 into 7, there's just not enough room, right, for them all to be even, and if they're all odd, then the parity doesn't work. 97 into 2, well, that's the case I was talking about, where n is odd and k is even. 8 into 8 is fine. 3 into 10, k is too big. 5 into 3 is fine. Okay. Not actually 100% sure totally what the solution is, but let's start coding it up. And, I think it'll be easier to figure it out so the rest is wrong. So we have n and k, and put in the boilerplate, input output. I don't know, in case we need vectors, usually need vectors. And long. Okay. So when is this actually impossible? You could sort of think that you want to do 100 pieces. Well, anyway, if n is less than k, or is even, or okay, so maybe another way to think about it is why shouldn't they all be odd? The only reason they shouldn't all be odd is if k is odd and n is even. You do have to give the actual representation, right? Yeah. So if they're all even, then we can just divide them all by 2 and solve for the case where they're not, I guess. So if they're I guess that's not really correct. Right, so imagine that they're all ones. Then, as long as the parity is correct, we're done. If the parity is not correct, then imagine that, right, because you can add any, +2 to like any of them. That's what I mean by the parity is correct. Any number of times. Right, so like, basically consider 1, 1, 1, 1, 1, n minus k plus 1, something like that. If that, is odd, then you're done. Otherwise, they all have to be even. And then you can do the same check, and otherwise it's impossible. So, okay. So the point here is that once we've sort of picked the parity, it must be positive. So the least thing you can have is 1s if it's odd, or 2s if it's even. And then you can add, once you've started with k1s or k2s, you can add just 2 to anything as many times as you want. So I might as well all be on the last thing. So even though it looks like there's a lot of different options that we might have to try, everything at the same parity adding up to n, really these two are the only options that we need to try. There's no point in distributing the +2s around any other way. So if these, try these two. If they work, great. If neither of them work, then it's impossible. 1 plus C out 2. C out 2. Use 226, fine. Yes, no, no, yes, no, yes, yes. Okay. Cool. Yeah, so as I said, these are the only two possible cases to try. Because sort of any other solution you could transform this way by just subtracting 2 from all of the other numbers, subtracting 2 from any of the initial numbers and adding it to the last number as much as you could. And that wouldn't change anything. So, okay, that's problem B.